Hello, hello. Hello, guys. Am I audible? Good evening, Said Roshan. How are you? Having fun? Doing good? Why is this voice repeating? Great. So, another session of the PYQs. Mm-hmm. Happy Diwali. Whoever has celebrated, uh, great wishes to all of you for Diwali. I hope Diwali went good for everybody. Nobody burned their hands or heads with the crackers, right? That's my voice can be a little bit low. Okay, don't mind. Too much of smog is there in the city right now because of the crackers loving people. I don't know who started this ritual of bursting crackers on Diwali. Yeah, it's fun, but very polluting, man. Totally. I used to do it a lot as a child, but as I grew up, now I've begun to hate so much. All right, so let's start with another topic of PYQs. I'll keep coming up with the PYQ series. I'll keep doing this as long as I can, and along with this, we'll keep doing our regular chapters also. Don't think that because PYQs have started, the other things, the other chapters or the other parts which we were doing on the channel before this are going to stop. Nothing's going to stop. Okay, I'll try to take integration this week itself, and one more PYQ session on one of the chapters. So, integration, yes, Syed Roshan. Next chapter, integrals only I'll start. I think Thursday or Friday max. Okay, it'll be there on the channel. Don't worry about it. So, all good. Let's start. Quadratic equations, guys. Easy topic. You have been studying this from your class 9th, 10th itself. But in 11th, so with the PYQ series, what I'm trying to do, I'll tell you, what I'm trying to do is we'll revise all the major concepts which are used in the mains paper especially. Advanced questions also sometimes will include, but right now our target is to revise everything for mains. I hope all of you have got the syllabus update. There is almost no change in class in 2023 syllabus and this year's syllabus, 2024 and this year's syllabus, all is going to be same. So you have to stick tight. uh, in quadratic equation, major concepts that we are going to explore, that we need to know, is relation between roots and coefficients, finding out the roots, then location of the roots. One very important thing is Newton's identity. So we'll try to revise and cover up all these sections through this session of ours. Okay, I don't think much people are there, but if you're going to watch the recording also later, I'd recommend that please take some time, solve the question on your own. That's the main thing which you need to know, because you need to build the thought before starting the question. What should I do, what do I know, and with the help of it, what can I how can I proceed ahead with the question. That's going to be our major, you know uh, strategy for solving any of the question. Okay, so we'll do step by step. We'll cover up all the topics which are majorly used in the JEE mains papers from quadratic equations. Along with that, we'll see which type of questions, what can be the level of question, what can be the perception which we might create by looking at the question. Okay, so let's start. Okay, first thing is basic, finding the roots, knowledge of the roots. Okay, let's start with that, or relation between roots and coefficients, which we know very well, thoroughly already. So this is your first question. Come on, read it and try to attempt it once on your own. Read the question. We'll start with very basic. if one real root of quadratic equation sorry, if one real root of quadratic equation 81x square, some quadratic equation is given where they are using k, is cube of the other root, then value of k is one of the value of k. We have to find single correct option. How will we do it? We know the connection between roots and coefficients. Simple thing which is given is 8, just a minute, 81x square plus kx plus 256. This is very basic of the thing, right? This is very basic of the thing, but mains can ask you questions from this part also. This is 2019, you'll see in 2023 or 22 also, this type of question is going to be there from quadratic equations in one of the sets. This can come to you. Sometimes we might end up making a mistake here also, but let's see this question. What is it saying? One root is cube of the other. So we know a quadratic equation is going to have two roots. One of the root we can take is alpha. Another root is the cube of this root only, so alpha cube. This is what the question wants to say. This is what the question is telling us. And now, as we have plotted this, as we have marked this, now we know that sum of roots, that means alpha plus alpha cube, sum of roots in a quadratic equation is equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square. So this is going to be equal to minus b by a. What is b here? B is k over here. So minus k by a. What is a over here? A is 81. Minus k by 81. That's simple. Okay. Now a value of k we need to tell. Alpha plus alpha cube. Okay. Alpha plus alpha cube means these are the two roots. Alpha and alpha cube are the two roots. One root is cube of the other. So alpha and alpha cube are the two roots. Now what else can we do over here? Uh, we can take alpha common, whatever you want to do, but here there is nothing derived from this particular part. So next thing, sum of the roots we know. Next thing we know is product of the roots. That means alpha into alpha cube. That means alpha to the power 4 is going to be equal to c by a. C is 256, a is 81. So c is 256 and a is 81. This is going to be the product of roots. Product of root means alpha into alpha cube. Correct? 256 by 81. 3 to the power 4 is 81 and 4 to the power 4 is 256, not 356. So alpha to the power 4 is 256 by 81. Alpha is going to be square fourth root of 256 by 81. That means 4 by 3. We got alpha. When we got alpha, we can find k from here very easily. We'll put it over here. That's it. 4 by 3 plus 4 cube by 3 cube is going to be minus k by 81. We'll put this. That's it. Simple thing. Do it yourself also. Please keep doing it on your own. All the questions I would recommend, try to do them once at least on your own. However easy they appear to you, however understanding or you are able to understand them very easily, even then please try to do all the questions. So one of the roots is alpha, which is 4 by 3, and alpha cube will be 4 cube by 3 cube. That means 64 by 27. So simple thing, 4 by 3 plus 64 by 27 is minus k by 81. From here we'll find this will give us k equal to I've not just a minute. I think minus 300 would be the answer. This is what you're going to get. Easily you'll find k's value. Okay, very basic of the thing. A little bit of calculation, not even calculation over here. This also you can do very easily. There is not going to be any problem in this. Okay. So k is minus 300. Very easy question, very basic thing. We know even if we didn't start with 11th class mathematics, with 10th class mathematics also we could solve this. But yeah, mains can give you these type of questions. Let's go ahead now. Let's go ahead. Number of real solutions of the equation. How many real solutions of this equation can we get? Actually, I think this had options. This is last year question only. Options. Let me check. What were the options here? Options are there in this question. No, this didn't have any options. This was integer type question or numerical question. Okay, so what would be the answer according to you? Now question has mod. First impression which might come in our mind is that Arey Baba, why mod and all is there? I think we'll have to take x greater than 0, x smaller than 0 in 3 cases, and then we'll have to solve, right? Either we can here we'll have to take x greater than 0, smaller than 0, open the mod. So much of complication. As soon as we see mod, most of the time what happens is that cases thing or cases concept start hitting our mind. That happens with us. That happens with us. I can totally agree with it. Yes, and that is only the common approach, that whenever you see mod, you have to build cases greater than 0, smaller than 0, and do it. But see how sometimes in JEE mains especially, the question will be very easy, but they'll include something to make it look horrible or difficult. Okay, they'll put a perception in your mind. Over here, what is it asking? Number of real solutions of this equation. How many real solutions of this equation? This entire thing is equal to 0. Sometimes actually mod makes things easy for us, because one thing it always tells us, that mod is always greater than 0. Okay, over here number of real solutions it is asking. Now this entire thing, if we talk about this x square plus 3 mod of x plus 5 mod of x minus 1, whatever, right, plus 6 mod of x minus 2. Now you tell me, this entire thing, whatever is the value of x, this entire thing will be positive or not? This will be positive, pakka positive, 100% positive, no doubt in that. Answer is 1. Yes, very good, Syed Roshan. Answer is 1. This entire thing is going to be positive, pakka positive. This is positive, this is positive, this is positive. Entire thing is positive. X square, whatever is the value of x, it is going to be positive. So this is never going to become negative. Either 0 it will become, or greater than 0 it will become. This is multiplied with x. This is multiplied with x. A product of a non-zero thing, positive thing, 0 or positive thing, with something is giving us 0. If this cannot be negative, that means over here x has to be equal to 0. This x has to be equal to 0. Then only this equation can be true. Either both of them will be 0, or at least this x will be equal to 0. X is 0. Only one case is giving us a 0. That means there is only one solution possible, which is x equal to 0. How simple this question is. But perception can make us can make it difficult for us to deal with the things. So always read your question very carefully and see how easily it can be solved. These type of questions should be marked and solved in seconds when you're going to give your JEE mains attempt. Okay, another easy concept, but looks of the question are changing our mind or putting things inside our mind. Now look at this question. Come on, read it. Simple question. Relation between alpha plus beta whole square and alpha minus beta whole square, or alpha plus beta and alpha plus beta whole square, alpha square plus beta square. Some simple relations we have already studied. We have studied these type of relations. Number of real solutions of the equations. This type is very common. Number of real solutions they'll ask you. You'll see this type of questions ahead also, because this particular type is very important. Practice this type as much as you can. Give it a while. So what is the general approach? What should be our approach doing this type of question? We'll assume something for x plus 1 by x. That is the approach. Come on, assume x plus 1 by x as some k or t. Okay, take this thing as t or k, whatever you wish. Okay. Now, if this is t, what will this be? How can we relate x square plus 1 by x square with x plus 1 by x? Whole square of this minus 2 will give us exactly this, right? Whole square of this will be x square plus 1 by x square plus 2. If we do minus 2, both will become equal, right? So now change your equation. This is going to become, this thing will become 3t square minus 2. T square, this is our t. So t square minus 2 times of t plus 5 equal to 0. Now solve for t. Correct? So what will this become? 3t square minus 6 minus 2t plus 5. Minus 6 plus 5 will give us minus 1. So 3t square minus 2t minus 1. 3t square minus 2t minus 1 equal to 0 is our equation. Can we solve this for t? Minus 2, so minus 3 plus minus 3 plus minus 3t plus t, right? This will become minus 3t plus t. Let's solve it only. 3t square minus 3t plus t minus 1 equal to 0. So 3, if we take common, wait, 3t if we take common, we'll have t minus 1 minus, if we take plus, if we take common, this is t minus 1 only, not a problem. So what do we have? We have 3t plus 1 as one root and t minus 1 as one factor. So what do we get from here? T equal to minus 1 by 3 or t equal to 1. There are two scenarios. Are these the number of solutions? Are these the solutions? No. This is t. We are looking for x. The equation is in x. So now we'll put the value. Either what can happen now? What can be the possible outcomes from here? Either my t, which is x plus 1 by x. What is my t? T is x plus 1 by x. Either this can be equal to 1 minus 1 by 3 or this can be equal to 1. Two cases I have. What will this give us? This will give us x square. Take the LCM, x square minus x plus 1. This x will go this side. Minus x plus 1 equal to 0. This is what we are getting. X square minus x plus 1. What is the discriminant here? B square minus 4ac. What is the what is going to be the discriminant over here? Discriminant b square, that means 1 square minus 4 into 1 negative. Here d will come out to be less than 0. So that means no real roots. This is giving us no real roots. NRR means no real roots. Here we are getting no real roots. What is the other case? X plus 1 by x is equal to minus 1 by 3. We'll check this one. This will give us uh, x square plus 3x. Sorry, wait. X square plus 3x minus 1. X square plus 3x plus 3. This will become x square plus 3x plus 3 equal to 0. Here discriminant is less than 0. Yes, 9 minus 12. B square minus 4ac is less than 0. Here also discriminant is coming out to be less than 0. Both the scenarios, both the possibilities, x plus 1 by x is equal to 1 by 3 is also not giving any real solution. Real solution it is asking about. Okay. And x plus 1 by x is equal to 1 is also not giving us any real solution. So how many real solutions are we going to get? We are not going to get any real solution of this equation. Solve carefully. This question teaches us what? That carefully solve. Here chances of doing a mistake are there. Okay, where can you do mistakes? You'll directly look at this equation and you'll see, okay, quadratic is forming. Two solutions from here and two solutions from here, and you could mark 4. But when they are asking about real solutions, check your discriminant. Check the value of d. B square minus 4ac, you should check. These basic things we know already. Okay. There is some visibility issue here. Just a minute. Okay, I'll not write on this side. I'll try not to write on this side. All right. Next question. Shall we move? Again, come on, give it a try. Just a minute. Is there, I think. I think now it's okay. Nahi. Read the question. Yeah, now it's okay. But I think the camera got a little bit tilted because of this. Right. Come on, read the question. Try to do this. I hope the question is clear. Let alpha beta be the roots of the equation. This is our equation x square minus root 2x plus root 6. And 1 by alpha square plus 1 by beta square plus 1 be the roots of this equation. Then the roots of this are. And they have not given the value of roots. They have asked about the nature of roots. Nature of roots again is a very important concept. Basic, but yeah, important. Okay, give it a try. What should be the answer? Doesn't matter you're watching it live or recorded. Please give every question at least a start. I would recommend at least start the question on your own. This is from 2022. Last question was from 23. As I told in the last session, that we'll try to cover up most of the PYQs which are from 20 to 24. Okay. Okay. So can we say about this equation, x square minus root 2x plus root 6. Alpha and beta are the roots of this equation. First thing, what can we start with? We can start with alpha plus beta. Alpha plus beta sum of roots equal to minus b by a minus of root 2 by 1. So it is going to be equal to root 2. Alpha beta, that means product of roots, c by a, so that is going to be equal to root 6. Okay. Now, next thing which they asked is, these roots are of this equation. 1 by alpha square plus 1 and 1 by beta square plus 1 are the roots of this equation. Now, another equation is, one more equation is given to us. This is x square plus ax plus b. And the roots over here are 1 by alpha square plus 1 and 1 by beta square plus 1. These are the roots. So, sum of roots over here can we find? Right, sum of roots very easily we can find sum of these two roots. That means 1 by alpha square plus 1 plus 1 by beta square plus 1. This gives us 2 plus 1 by alpha square plus 1 by beta square. That means alpha square plus beta square divided by alpha square beta square. This we know how to solve. Alpha plus beta we have, so alpha square plus beta square. Alpha square plus beta square will be alpha plus beta whole square minus 2 alpha beta. Correct? Alpha beta also we have. So this is going to become alpha plus beta whole square. That means root 2 square minus 2 times of alpha beta. That means 2 root 6 divided by alpha square beta square. That means 6. So this will give us 2 minus 2 root 6 by 6. And there is a 2 already there. So plus 2. This is sum of roots. I'll write over here sum. Product, we can use product also. Product of these two. Product of these two. 1 by alpha square plus 1 multiplied with 1 by alpha 1 by beta square plus 1. This will become 1 plus, this will become product of these two. So 1 plus 1 by alpha square plus 1 by beta square plus 1 by alpha square into beta square. Correct? 1 by alpha square into beta square. Right? Product of roots directly. Multiply these two. This one and this one. So 1 plus 1 by alpha square plus 1 by beta square plus 1 by alpha square beta square. That is what we are going to have. Here also there is no problem. 1 by alpha square beta plus into beta square we can directly put. Can you directly tell me the value of this? This part we already know. This part we already know. We just now found alpha square plus beta square plus up divided by alpha square beta square, and 1 plus this. So 1 plus 1 by 6. That means 7 by 6. So this will become 7 by 6 plus 2 minus 2 root 6 divided by 6. This will become the product of roots. Sum of roots is going to be equal to, this is going to be equal to minus a. Minus here, what is your coefficient of x? Minus a. And product of roots is going to become equal to c by a, that means equal to b. This will become equal to b. So what will be our a, this thing, a plus b only we need to find. Can we write over here? Yeah, right. So what will a plus b become? A plus b, that means this plus this. This will become minus 2 and 2 root 6 minus 2 upon 6. So the sum of these two will become minus 5 by 6, right? A plus b, when we'll do, this part will go away and a plus b will directly come out to be minus 5 by 6. Okay, that's what we needed. Okay, and a plus b, if we'll put over here, we'll just put this a plus b over here. So what we'll have, x square minus a plus b minus 2, minus 5 by 6 minus 2. So minus 5 minus 12. So it will become positive 17 by 6. Minus minus will become plus, positive 17 by 6 plus 5 by 6. Oh, this will plus 2 when we'll do, we'll have 7 by 6, sorry. 7 by 6 only will remain. 7 by 6. This will be our equation, right? And this is basically 6x square plus 17. Okay, here there will be an x plus 17 plus 7 equal to 0. Now, for this, can we tell the nature of roots? Entirely positive equation. So, like all the terms, all the coefficients are positive. So, both the roots of this equation are going to be, are we going to have distinct roots? Are we going to have distinct roots? Yes, distinct roots. D is greater than equal to 0 over here. D is greater than 0, not even equal to. D is greater than 0. So distinct roots, and both positive roots because all the coefficients are positive. So both the roots are going to be positive. Real and both negative roots. All coefficients are positive. So both the roots we are going to get are going to be negative, and D is greater than 0. So distinct. Do we have what options do we have? Both the roots are negative and distinct. Right, distinct part is not given here. Real and both negative. Real definitely, and both are going to be negative. Okay, this again simple question. Only manipulation of roots, manipulation of the calculation of roots over here. This you need to know very frankly and easily and confidently. So this part, from this basic part of the quadratic equation, also many questions are asked. Solve as many as you can of this type to cover up quadratic equations questions. And quadratic equation along with complex number is a high weightage chapter, right? You're definitely going to get some questions. See, when suppose this type of question comes in your paper, okay, this type of or last 2-3 types of questions came in your paper, What is your main target? This time we have 25 questions. So main target for 99 percentile, let's maximize it, and let's keep it 15-16 questions you need to attempt. And one question can be solved this easily in clicks. So you have no chance of doing this wrong. You should keep no chance of doing these questions wrong, at least not at all. If these type of questions appear in your exam, you should solve them in just clicks, in seconds. Or for this one, with some calculation you can take a minute, but cannot take a risk of leaving these type of questions. Okay, very favorite things. Okay, now they included a little bit of trigonometry in not little bit of, just sine they have included. Okay, quadratic equation question, trust me guys, is never going to be difficult for you. If this appears, is this topic appears in your exam, try that you are able to solve the question from there. They might make it look a little bit difficult or tricky or horrible, or using some different or random concept from other chapters, but it is not going to be difficult at all, because quadratic equation is just supposed to be strong with everybody. Little bit of practice is going to give you marks in this chapter. E to the power sin x minus 2 e to the power minus sin x is equal to 2. Number of solutions, again, number of solutions. This is the favorite category for JEE Mains. Number of solutions. You know what to do over here? E to the power sin x. You'll put this equal to t. Take this as some t. Okay, e to the power sin x. Obviously, we cannot solve. It is a quadratic equation. It is a quadratic equation, we can see, but we cannot solve it like this, in this format. Now, how do we realize? We might think that, sir, it is an equation in E or exponential equation, but if we do this, isn't it a quadratic equation? Why am I saying this? Because if e to the power sin x is t, then this equation becomes t minus 2 by t. E to the power sin x minus sin x will become 1 upon e to the power sin x, and this will become t minus 2 by t equal to 2. Very simple quadratic equation, we know how to solve. What do we have? T square minus 2t minus 2t minus 2 equal to 0. Okay, did we do something wrong here? T square minus minus 2 only. Okay, now solving this, next thing is how to go ahead from there. Solve for t, and then you can, if you want, directly solve for t, right? Directly solve for t using the quadratic formula, you'll get the roots. Or one more thing which you can do over here is split the middle terms. Minus 2 you need, so what can we do? 1 minus 3, 1 minus 3, but it is not giving us 2, right? So what manipulation you can do? T square minus 2t plus 1, if you do, right, it is going to be t plus 1 whole square equal to plus 1 and minus 3, right, equal to 0. This manipulation you can do over here. So this will become t minus 1 whole square equal to 3. And from here, what you can say? You could solve for t directly using quadratic formula also, but this is a bit of smartness, that what you can say, t is going to be equal to root 3, or this is t minus 1 will become equal to plus minus root 3. So t can be given equal to 1 plus or minus root 3. 1 plus or minus root 3. What are they asking? Number of solutions again. So t, what did we take t as? We know e to the power sin x, right? Our e to the power sin x is coming equal to 1 plus or minus root 3. Root 3 is 1.7 something. Okay, you know that. And e to the power something, e to the power, e is a exponential function which is going to be positive for sure, right? So can we take e to the power sin x as 1 minus root 3? 1 minus root 3 will become negative. So we have to take 1 minus root 3 will be rejected because it is less than 0. Okay, it is less than 0. So what is our e? E is e to the power sin x is equal to 1 plus root 3. Yes, this has no problem. So from here, what do we get? Sin x equal to ln of 1 plus root 3. 1 plus root 3, 1.73 something plus 1, 2.73 something, right? 2.73 something. Now, ln of 1.7, ln of 2.73 something, ln of 2.73 something is going to be greater than 1 for sure. Can we say? Can we say sin x is going to be equal to ln of 2.73? That means sin x is definitely going to be greater than 1. This part is going to be greater than equal to 1. Not equal to also, greater than 1. Is this possible? Sin x lies between -1 to 1 always. So this is not possible. Correct? This is not possible. Sin x will be between -1 to 1. We know. This basic we know. So there is no real value of x which is going to satisfy this. So what should be our answer? No solution. 0 should be our answer. This is not possible only. How can sin x be greater than 1? Not even equal to y. This is going to be giving us greater than 1. Is this possible? Think about it. Can there be any solution? There is no such solution which will satisfy sin x greater than 1. Ln of 2.73 is going to be greater than 1 for sure. Correct? Little bit of knowledge of log, and we should just know sin x lies between -1 to 1. That's it. We didn't actually need any complex concept over here. Only confidence for doing this, for starting from here. That's it. Confidence. Again, I'm telling you, quadratic equation questions must be attempted. All of them. Very minimal concepts. Revise them. Keep them very thorough with you. If a question appears, and definitely it is going to be 100% possible that quadratic equation question or complex number and quadratic equation mixed might be there in your question, is going to be there in your question paper for mains. Attempt this. Target is attempting 15-16 questions. So these type of things should be very confident. If this comes, I'll attempt this. If tangent normal comes, I'll pakka do that correct. If coordinate geometry something comes, I'll do that correct. This is how you can aim for 99 percentile. Objective is to be able to attempt at least 16 questions, right? Now your choice is also removed. Earlier, last year, people used to do 5 questions from the integer type. Out of 10 questions, only 5 they used to attempt. This time, it's not going to be there. Definitely, score for 99 percentile will be lesser. Number of questions attempted will be lesser. Mark it. Okay. So, simple concept should not be left. If difficult concept is coming, yeah, you have to keep a scope of at least 7-8 questions which I'm not going to attempt only. And these, most importantly, these questions are going to give you time. That's what you need. These type of questions are going to give you time for tricky questions. So this management also you are going to need too much. Okay, let PQ, next question from 2019, let PQ belong to, teachers, if 2 minus root 3 is a root of quadratic equation, x square plus px plus q equal to 0. This is a quadratic equation and its roots are two minus root 3 is one of the root. Irrational roots always occur in conjugate pair. Irrational roots always occur as conjugates. Conjugates means if one is 2 minus root 3, then other will be 2 plus root 3 for sure. Small, very minimalistic of the knowledge. Very, small concept you are needing here. But if you forget that concept, you'll get stuck in this question. You'll keep solving this. This will waste your time. Right? So we should know if 2 minus root 3 is given as a root of a quadratic equation, another root is going to be 2 plus root 3 for sure. This thing you need to know. Right? So if one of the root is 2 minus root 3, another root is going to be 2 plus root 3. Simple information you need to know for this. Now what? Sum of roots. Sum, that means 2 minus root 3 plus 2 plus root 3 will be equal to minus p. So 4 or minus 4 is going to be equal to p. What will be your q? 2 minus root 3 into 2 plus root 3 a square minus b square. So q is going to be equal to 4 minus 3. That means 1. You have p, you have q. You can easily check. Check. Which one is correct? 16 minus 4 is equal to 12. Right? P square, that means 16 minus 4 into 1. So 16 minus 4 equal to 12 is correct. No, 16 minus 4, 12 plus 12. This will become 24. So this will be correct. 16 minus 4, 12 minus 12 will be equal to 0. Easily you'll be able to see. 5-10 seconds. Right? You in exam you won't be writing this much, right? Here I'm writing. In exam you'll simply say, okay, 2 minus root 3. That means 2 plus root 3 is going to be another root. Sum of roots is going to be equal to 4. Product of roots is going to be equal to 1. P is equal to minus 4, Q equal to 1, tuck. Clicked. Okay, simple concept. Many times it is used. That irrational roots occur in pair. In complex number also, if the roots are complex, they'll also occur in complex conjugates. Right? Okay, next question. Come on, give it a try. All the relations you should know, right? Alpha plus beta for, I'll write once, ax square plus bx plus c. If your roots are alpha and beta, then your alpha plus beta, very basic thing, but these small things should be making things easy for you. And one more, alpha minus beta, difference of roots is square root d, square root of discriminant divided by mod of a. Difference of the roots. Okay, this concept is going to be required. Difference of the roots, because they are asking about difference of the roots, mod of alpha minus beta, which is going to be equal to square root d divided by mod of a. D is your b square minus 4ac. Come on, give it a try. This information, roots are in AP. That means your 2q is going to be equal to PR. This we know. Oh, not PR, P plus R. P plus R is going to be equal to 2q. These two informations, that's it, and one formula for difference of roots. You can solve it very easily. Come on, give it a try. Take your time, give it a try. Please solve them once on your own so that this chapter can be practiced even in less than 2 hours, 1 or 1.5 hours. Okay, with PYQs, variety of PYQs. The reason for this series is this much only. So please keep practicing, keep doing the questions on your own. What is our equation? So I'll write just information. The equation is px square plus qx plus r. Roots are alpha and beta, are the roots of this equation. So now alpha plus beta, can we derive alpha plus beta from here? Alpha plus beta is going to be equal to minus of coefficient of x, that means minus q, divided by coefficient of x square, that means p. And product, that means alpha beta is going to be equal to r by p, because c by a. Okay. What are we getting from here? This is giving us some information. Use every information in the given in the question. Be very quick with it. Okay, this much is done. Next we can use this. This will give us alpha plus beta. This will give us alpha plus beta is equal to 4 alpha beta, or we can also say alpha plus beta divided by alpha beta is equal to 4. Okay, what is alpha plus beta? Minus q by p. What is alpha beta? R by p. So this is going to be equal to minus q by r. What do we need to find? Now we have used all the information. We have written down all the information wherever we can use. Now what are we going to need? AP, third information. One more information is there, right? One more information is there. Can we use it over here? Can we use this information over here? The relation between PQ and R is there, no? So we can use it over here. We can build a, see, what do we need to find? We need to find alpha minus beta mod, which is equal to square root of d. Sorry, that means square root of b square minus 4ac, that means 4pr divided by mod of p. This is what we need. So we cannot find it until unless we have a relation between p and q and r. What relation we have? We know that 2r is going to be equal to p plus 2q. 2q is going to be equal to p plus r. This relation we know. How can we use it? Q is equal to minus 4r. Can we put Q is equal to minus 4r will give us minus 8r is equal to p plus r. So p will become minus 8r minus r, that means p will be equal to minus 9r. Correct? Over here, p, q and r. Everything can we put in terms of r now? Can we put everything in terms of r? We have q and p only now. What will q become? Q square. Q square. Q and r are already related, right? So q square will become minus 4r whole square. This will become square root of minus 4r whole square. That means 16r square. Minus 4 into p into r. P and r relation is here. Here also we can put everything in terms of r. Minus 4 into minus 9r. That means plus 36r. Right? This also we are using. P is equal to minus 9r. Now this mod p, that means mod of this, that means 9 mod of r. 9 into mod of r. That's it. What will this become? This will become 16 plus 36, 52, right? 52. And here, wait. Minus 9r into 4 into r. So this will also be square. So we are going to have 52 r square square root divided by 9 mod of r. Mod of r, square root of r square. Square root of r square will become square root 52 multiplied with mod of r only. Square root of r square will become mod of r only. So mod of r and this mod of r are going to get cancelled. All the information we used very correctly, very aptly, and simply this question could be done. Here we should get, after doing this, this is what we need to find. So relate everything, whatever information is given, put it over here. Q, P and R are there. We cannot solve it if all the terms are there, all the variables are there. We can only solve it if we have everything in one variable. Then there is a chance because division is happening. So now this is just square root 52. Square root 52 means square root of 13 into 4. Hey, 9 is also there. 9 is also there, right? Here 9 was also there by 9. This entire thing. Just a minute. So 13. So 2 root 13 by 9. This will be our answer. Right? 2 root 13 by 9 will be our very easy answer. This is asked in 2014. Okay, very long back, but yeah, important variety. Sometimes we forget this and we start doing this by relating alpha plus beta and alpha minus beta. No, remember this, alpha minus beta, difference of root, mod of difference of roots is equal to square root d by mod of a. Okay, I'll write also alpha minus beta is going to be equal to square root d by mod of a. Important things, small but important things. Are we clear? Let's move to next. This time again they tried to make the question look horrible. Okay, but whenever irrational numbers are coming in your quadratic equation question and very similar type of irrational number is coming, this type of irrational number, pay attention. Okay, root 3 plus root 2 and root 3 minus root 2, conjugates. Can we turn it into a simple quadratic equation? Will we be able to turn it into a simple quadratic equation? Yes or no? Check once. We'll take anyone. We'll take root 3 plus root 2 as some k. K or t, whatever. Right? Now, if root 3 plus root 2 is k, what will be root 3 minus root 2? What will be root 3 minus root 2? I'll just do over here. Root 3 minus root 2, if you see, how will you rationalize it? You'll multiply it with root 3 plus root 2 and divide it with root 3 plus root 2. What will you have here? Here you'll have 3 minus 2 and denominator will become 1 by root 3 plus root 2. This. These two are equal. Root 3 minus root 2. If root 3 plus root 2 is k, then root 3 minus root 2 will be equal to 1 by k. So this is a simple quadratic equation. No, not as that simple also right now. So don't assume root 3 plus root 2 only as k. Assume this. So this will become 1 by k. Assume root 3 plus root 2 to the power x whole to the power x as k, and this will be 1 by k then. Not going to be a major problem. Okay. So let's remove this part. Now we can write our equation very easily. K plus 1 by k equal to 10. Correct? This thing you understood, right? If root 3 plus root 2 to the power x is taken as k, then root 3 minus root 2 to the power x will be 1 by k for sure. Conjugates. Root 3 minus root 2 is nothing but 1 by root 3 plus root 2. Okay. After that, what can we say? So yeah, if this is k, then this will be 1 by k, or here what you can write is, let it be like this only. Let me write this again. This part is going to be important. Understand this part. Many times we get stuck or we go blank at this type of question because we think, it is not quadratic equation, it's some other exponential equation. And 90%, 95% of the times, if an exponential equation is there, it is going to turn up into a very easy quadratic equation, mark my words. Okay. So k plus 1 by k equal to 10. This we know how to solve. This will just become k square minus 10k plus 1 equal to 0. This we very easily know how to solve. What can we break this? No, we cannot break this. Minus b plus minus. This we'll have to solve with quadratic formula. Minus b plus minus square root of b square minus 4ac. So 10 plus minus 100 minus 4 into 1. That means 96. So 10 plus minus square root of 96. That means 4 root 6. 36, 4, right, 4 root 6. No, 16, 96, 96, 96. 16 into 6. 16 into 6. So 4 root 6, correct. This will give us k equal to, k will come out to be equal to 10 plus minus 4. 4 root 6 divided by 2a. So that means 2. That means we have k equal to 10. Oh no, not 10 now. 5 plus or minus 2 root 6. This is going to be our k. Something to the power x, exponential function. Can it be negative? Can it be negative? No. What are they asking again? Number of elements in S. If S is this, x belonging to R, number of real solutions of this for x, number of real values of x. What was our k? We'll put it again. Keep solving it along with me. If you're not able to start, at least solve after the part where I'm solving. Okay, I'm giving you enough time. Right? We are not doing many questions, but if you can solve them with me, that will be very helpful and productive for you. Okay, k we took as root 3 plus root 2. So our k is root 3 plus root 2 to the power x can be equal to either 5 plus 2 root 6 or your root 3 plus root 2 to the power x can be equal to 5 minus 2 root 6. Now what is the main thing over here? You should be able to see that root 3 plus root 2 whole square is nothing but 5 plus root 3 plus root 2 whole square. Root 3 plus root 2 whole square is nothing but 3 plus 2 plus 2 root 6. That means 5 plus 2 root 6. This is the square. So from here, from this one, what are we getting? X can be equal to 2, right? From here we are getting x can be equal to 2. From the other part, which is root 3 plus root 2 to the power x, which is 5 minus 2 root 6. This will still be greater than 0. Okay, don't think it will be negative. So this is possible. What can we do over here? Again, conjugate thing. Five minus 2 root 6. So what should be the power over here? Minus 2. Yeah. Why? Because see, 1 by root 3 plus root 2. What is this? This is nothing but root 3 minus root 2. If you rationalize this, you'll get this. Correct? So what is this? Can we also say root 3 plus root 2 to the whole power minus 1 equal to root 3 minus root 2? Correct? And square of this, that means root 3 plus root 2 to the whole power minus 2 is going to be equal to nothing but 5 minus 2 root 6. So here power is going to be minus 2. So either x can be equal to 2 or x can be equal to minus 2. So how many solutions can we get? We can get only 2 solutions. X can have only 2 values. Again, basic question, looked horrible, can be broken into simple quadratic equation. Here you can get stuck, but you should be easily able to see that, yeah, root 3 plus root 2 and root 3 minus root 2 are connected very well. Okay, reciprocals of each other. This thing will click very easily for you. Root 3 plus root 2 whole square is 5 plus 2 root 6. So here finding x won't be a trouble. Okay, finding x won't be a trouble for you. Shall we move ahead? Okay, next question. This variety is also very important. Okay, when they include AP and GP. So simple relation of AP and GP you have to use, right? Whenever they include AP and GP, they want you to use the concept of AP-GP over here, nothing major. If alpha beta are the roots of px square plus qx minus r, p not equal to 0, p, q, r are consecutive non-constant terms of GP. Non-constant terms, that means r is not 1. Okay, common ratio is not 1. Okay, are the non-constant roots of GP. Then 1 by alpha plus 1 by beta is equal to, and this relation is given. Then they've asked alpha minus beta whole square. They've asked alpha minus beta whole square. There are 3 terms. There are 3 PQR. So what can you do? PQR are 3 terms of GP. You know how to choose 3 terms of GP. Let's say AR and AR square. Okay. AR and AR square. This relation, you know, this information you can use from GP concept, GP chapter. Then alpha beta are the roots. So what you can do, okay, alpha beta are the roots of this equation. So alpha plus beta is going to be equal to minus q by p. And my alpha beta is going to be equal to minus r by p. This you can use. Both are connected, right? So alpha plus beta will take from here minus q by p. That means minus of AR by A. Minus AR by A. So minus R. Correct? Alpha beta, that means product of roots, is going to be equal to minus R by P. So AR square by A, that means R square. Right, complete thing. AR square by A. So minus was also there, right? So minus of AR square by A, so that means minus R square. And then last information which we can use is this: alpha plus beta upon alpha beta. Alpha plus beta upon alpha beta is given equal to 3 by 4. What do we need? Alpha minus beta whole square, no? That means alpha square plus beta square minus 2 alpha beta. Correct? For that, what do we need to find? We need to actually find R. We need to actually find R, because Q and P ka value, how will we replace? Right? How will we replace Q and P ka value if we don't have R? So we actually need R over here, right? That is our focus. Now here we'll put alpha plus beta, that means minus R, and minus R square. So that means minus R upon minus R square is 3 by 4. That means my R, 1 by R, actually, my 1 by R is equal to 3 by root 3 by 2. No, 3 by 4 only. Right? So my R will come out to be, from here, what will R come out to be? R will come out to be, common ratio is 4 by 3. Common ratio is 4 by 3. So what we'll do, we'll connect this over here. Or we can directly use alpha plus beta upon alpha beta also. We actually don't, because we don't have A, right? We don't have A. We have this. What do we need? We need, let's not do this. We need alpha minus beta whole square, which is nothing but alpha square plus beta square minus 2 alpha beta, which can be written as alpha plus beta whole square minus 2 alpha beta minus 2 alpha beta. So shall I directly write minus 4 alpha beta over here instead of doing this much? So this will become minus 4 alpha beta. Correct? Alpha square plus beta square can be written as, in terms of alpha beta, alpha plus beta and alpha beta, we have written this. So now what we can do, alpha plus beta whole square, that means minus R whole square, so R square. Minus 4 alpha beta, that means minus into 4 into minus R square, that means plus 4 R square. So this will become 5R square. That means 5 into 16 by 3. 80 by 3. Oh, wait. 16 by 9. 4 by 3 whole square, no? So 5 into 16 by 9, that means 80 by 9. Okay, simple concept. GP they have included. So whenever this happens, know that first write the properties of GP which you can use in the question. Very common variety, they'll put AP or GP in quadratic equation question for sure. Very good, Kevin. How are you? 80 by 9, correct. Great. Let's move ahead. Again, exponential equation looks like an exponential equation, but as I told, 95% of the times it will be a question of quadratic equation. It might not look like that. Try this once on your own. Here they have again asked about nature of roots. I'll use another page. E to the power, we have e to the power 4x, just a minute, plus 8 e to the power 3x, plus 13 e to the power 2x, minus 8 e to the power x plus 1 equal to 0. For this we need to find nature of the roots, or nature of the values of the x. So what we'll do, convert it into a simple quadratic equation, put e to the power x as some t or k, some other constant. So equation will become t to the power 4, let over here, t to the power 4 plus 8t cube plus 13t square minus 8t plus 1 equal to 0. Not a quadratic equation. What will you divide? divide by t square. So this will become t square plus 8t plus 13 minus 8 by t plus 1 by t square. This is what you're going to get. Now what you can do? Now it is a quadratic equation for you. T square plus 1 by t square you can put together, right? And plus 8t minus 8 by t you can put together. So that you can take 8 as common, right? Plus 13 equal to 0. T square plus 1 by t square plus 8 into t minus 1 by t plus 13 equal to 0. Just writing as many steps as I can. Okay, this you know how to solve, right? This you know how to solve. You will again, this type of question we solved just now. Same type of question we solved just now. T is 3 or 5. Okay, good Kevin, keep solving. Great. So put something else. Let's take k. If we take t minus, I'll put over here t minus 1 by t. I'm taking as some k. Okay. So what we'll have? We'll have this will become k square minus 2. Sorry, k square plus 2. K square plus 2. In square of this, t square plus 1 by t square minus 2 plus 2 if we'll do. This we'll have. So this will become k square plus 2 plus 8k plus 13 equal to 0. This will become k square plus 8k plus 15 equal to 0. So 5 and 3, right? So from here what do we get? K can be equal to 5 or it can be equal to 3. Minus 5 plus 5 plus 3 minus 5 and minus 3. Minus 5 and minus 3 we are going to get. So again redistribute. What was k? K was t minus 1 by t. So my t minus 1 by t can be equal to either minus 5 or t minus 1 by t can be equal to minus 3. I'll get two equations from here. T square minus 5t minus 1 equal to 0 or t square t square plus 5t minus 1 equal to 0 and t square plus 3t minus 1 equal to 0. T square plus 5t minus 1 equal to 0 or t square plus 3t minus 1 equal to 0. These are the two cases for t I'm going to get. T is still yet to be distributed there. Now, one important thing which we need to know over here is that t is my e to the power x. So t has to be positive. T has to be positive. E to the power x is positive always, right? T has to be positive. What are the values of t I'm getting? My t's values over here, t. Okay, this will become, no, we'll have to use quadratic. So 25 minus 5 plus minus 21. Okay, when you're saying minus 3 plus root 13 by 2. Huh? Root 29 minus 5, na? 29 it will be. T will, from here what we'll get, t will be minus 5 plus minus root 29 by 2 or t will be minus 3 plus minus root of 13. Yeah, from here we are getting 13. 9 plus 4, yeah, plus minus root 13 by 2. Okay. Now the thing is that my t has to be positive. So minus 5 plus minus it will be. Let me put a 3 over here. Minus 5 minus root 29 we don't consider and minus 3 minus root 15 we won't consider. So my t can be equal to minus 5 plus root 29 by 2 or minus 5 plus root 29 to will be positive, right? Pakka positive. Root 25 is 5, so this will be greater than 5. Or minus 3 plus root of 13. Again, root of 13 will be greater than 3, right? So, not plus minus, plus root of 13 by 2. These are the possible values of t. So, my e to the power x can be minus 5 plus root 29 by 2, or e to the power x can be minus 3 plus root 13 by 2. Huh. So, x can be equal to ln of minus root 5 by 2 plus root 29 by 2, or e to the power x, from here x can be equal to ln of minus 3 by 2 plus root 13 by 2. What did they ask in the question? I forgot. They asked, okay, nature, 2 solutions and both negative, negative, positive, 4 solutions. Number of solutions are 2. So this is wrong and this is wrong for sure. 2 solutions we are getting. 2 solutions, only one of them is negative. 2 solutions, both of them are negative. So what do you comment after looking at this? Come on. What's your say after looking at this? Both negative only, right? Root 5 by 2. Tell me. Just a minute, please. Can we easily think about this? This thing. What is this? This is ln of your 13 minus 3 minus ln of 2. Pakka less than 0. This will be greater, this will be small, this will be smaller, this will be greater. So this will be less than 0. Over here also same thing. Ln of root 29 minus 5 minus ln of 2. Less than 0, this will be 1, somewhere around 1, this will be more than that, and this is also your less than 0. Both the roots are negative. Minus 5, not root 5, sir. Minus 5. Minus root 5. Acha, हाँ, sorry. Minus 5 here. Minus 5 here. Minus 5. This also minus 5. Both roots will be negative. Root 13, ln of 13 minus 3 minus ln of 2 will be less than 0 for sure. Both 2 solutions only we are getting, and both are negative. Both are negative. Sound low. It's Nehru. Sorry for that. Maybe because of my throat. All right. Next. This question was from 2023. Again, one more question from last year. Come on, give it a try. Mod is included there. Very complex looking question, but it won't be that complex. lambda belongs to R, there is some lambda which is a real number, let the equation E, equation's name is given to us, then largest element in S, when S is equal to x plus lambda and x is an integer solution of the equation. X is the integer. Too much calculation. Yes, Kevin. Too much calculation. Which here too much calculation? Yeah, only this part. You'll if you do logs a little bit also, no, you'll understand this part. Hmm? Okay. Now, come on, give it a try. Now, when again, as I told in the first question, if you're sitting from the starting, as I told in the first question, as soon as we see mod, the cases start appearing in our head. We'll start thinking that okay, cases are going to be there. We'll have to apply cases. So how will you attempt? How will you approach this question? Come on, try to think once. Try to think once. Give it a try. Mod of x square minus 2 mod of x plus lambda minus 3 mod. Mod came here. So what you'll say? You'll say, okay, this is always positive. This you'll say less than 0 or greater than 0. You'll try to make cases. Correct? You'll try to make cases, and again, here you'll make cases for x, then for lambda also you'll have to make cases. For x, you'll say that okay, x can be greater than 0 or x can be less than 0. Surendra Mohan Gupta, hi. Hi Surendra. Definite integrals soon. Okay, integration and after that, definite integrals. Yes, Harish. Here I'm saying, try to pay attention, try to solve them now, solve these now. What I'm saying is, first thought which will come in your mind is that, okay, mod is there, so I'm going to make cases. What will I say? First I'll make cases for x. Okay, if x is less than 0, then this will become x square minus plus 2x, and then for lambda also I'll have to make cases. First two cases for x less than 0, x greater than 0, then two cases for lambda less than 0, lambda greater than 0, lambda minus 3 less than 0, lambda minus 3 greater than 0. So four cases you'll have to make, and you'll be checking in that direction. It will make it complex. But whenever you see x square minus 2x, t square minus 2t or something like that, right? One more thing hits your mind. What is that? That we can make a whole square over here. So that direction you should proceed with. What I'm trying to say is, what you can do is here, over here is x square, because see, whole square is always going to give you positive thing. So cases are going to be reduced. Whenever you see, no, x square minus 2x, something like that, make a whole square, try to make a whole square. So x square minus 2 mod of x, if I do plus 1 over here, this will become a whole square. This will become mod of x minus 1 ka whole square. Correct? And if I've added plus 1, then here also I'll have to add 1. Correct? Now what? This will become lambda x, sorry, mod of x minus 1 whole square, which is always going to be positive, plus mod of lambda minus 3, which is equal to 1. Now this is greater than equal to 0 always. This is also greater than equal to 0. If both of them are greater than equal to 0 and their sum is equal to 1, what is the possible case? Both are positive and sum is equal to 1. Can two positive things give you sum equal to 1? If one is positive, one is negative, there are many possibilities for getting 1. But if both are positive, that means there is only one possible case for getting 1. Correct? There is only one possibility now. Either this is 0 or this is 0. I'm sorry, either this is 0 and this is 1, or this is 1 and this is 0. Then only we can get 1. Now both are positive. This is also positive, this is also positive. Two positive things adding and giving us 1. Not possible only. Only one case it is possible, that this is equal to 1 and this is equal to 0, or this is equal to 0 and this is equal to 1. Two cases only. Yes or no? Now this part, total number of integral solution, x is an is x plus lambda, and x is an integral solution of E. Largest element they are asking. They are asking about largest element in this set. Okay, we'll check the set first. So two possibilities, that means case 1 and case 2. So first case tells us, let's say that this is equal to 1. Let's take this equal to, or let's take this equal to 0. Let's say that my mod of x minus 1 whole square is equal to 0. What does this give me? This gives me mod of x equal to 1. That means x equal to plus or minus 1. Correct? If x is equal to plus or minus 1 and this is equal to 0 and this I'm taking as 1. This is my first case, and I'm taking my lambda minus 3 mod of lambda minus 3 equal to 1. I took this as 0, so this as 1. Now from here what will I have? Lambda minus 3 equal to plus minus 1. That means lambda can be equal to minus 1 minus 3. That means minus 4. Lambda can be equal to minus 4, or lambda can be equal to plus 1 plus 3. Minus 1 plus 3. Wait. Lambda minus 3, right? So minus 1, if we are taking, minus 1 plus 3 will give us 2. And if we are taking plus 1 plus 3, that means 4. 2 and 4. Two cases for lambda, right? X can be plus minus 1 and lambda can be 4 or 2. Second case, what is my second case? Second case is this as 1. That means lambda x, mod x whole square minus 1 mod x minus 1 whole square equal to 1, and my lambda minus 3 equal to 0. So from here what will I get? What are the possibilities? X can be plus minus 1 again. X can be plus minus 1 and lambda can be equal to 3, right? Lambda can be equal to 3. So from here I'm getting x is equal to plus minus 1 and lambda equal to 3. Now which sets? We are talking about x plus lambda. X plus lambda possible values are, from here what possible values? We can get plus 1, plus 2, 3. Minus 1 plus 2, no, plus 1 only. Plus 1 plus 4. Maximum we need to write. Plus 1 plus 4 is giving us 5. Right? If we take plus 1 from here and plus 4 from here, we are getting 5, and more than 5 we cannot get for x plus lambda. From here, plus 1 plus 3, 4, minus 1 plus 3, 2. So no, we are getting maximum value of x plus lambda as 5. They are asking about largest element in this set. That means largest element will be equal to 5. Easily we could calculate this. Largest element over here is equal to 5. Correct? Largest element. But if we go by cases right from the starting only, we could take time. That is also one way, but it will take much more time. The key thing over here was, don't be afraid of mod. Not always you are going to make many cases. Second thing is that if you see something like this, try to make a whole square. Making a whole square makes things easier for us. That's how we solve this. Similar type of question, not this one. Last one which we solved. This type is very common. In 2023 and 24 also similar type is asked. Okay, same. Exponential equation could be turned into a simple quadratic equation, right? So pay attention at these type of questions especially. Okay, let's move on to next. This is again last year only. This variety you must have seen if you have solved PYQs. Not that difficult of a question, very easy manipulation will be here, right? Let A belong to R, let A, B be the roots of the equation. A, B, not A, B, it's alpha, beta. This will be alpha, beta, I think. Alpha, beta. Then possible values of A they are asking. Right? They are asking possible values of A. A, B, how can they be the roots? Must be a misprint. Alpha, beta will come over here. Okay, alpha beta are roots of this equation, x square plus 60 to the power 1 by 4 x plus a. Right, alpha and beta are the roots. If alpha to the power 4 plus beta to the power 4 is equal to minus 30, this is also given to us. So we'll simply do first thing, what we know is alpha plus beta will be equal to minus 60 to the power 1 by 4 sum of roots, and alpha beta will be equal to a. If roots are alpha beta, then product and sum we can write very easily. Now second information which is given to us is this, alpha to the power 4 plus beta to the power 4. So alpha to the power 4 plus beta to the power 4, how can we write it in terms of alpha plus beta and alpha beta? It will become alpha square plus beta square whole square. First thing, alpha square plus beta square whole square will be alpha to the power 4 plus beta to the power 4 plus 2 alpha square beta square. So we'll just subtract this. 2 alpha square beta square will subtract. This also we can write alpha plus beta whole square minus 2 alpha beta to the whole square minus 2 alpha beta whole square. Now everything is in terms of this thing. Right? This is given to us equal to minus, yeah, here there is a minus. Minus is here, 30 is there, my bad. Minus 30. This is given to us equal to minus 30. Now solve it. Simple equation now. Right? This we can solve. Alpha plus beta we know is minus 60 to the power of 1 by 4 square of this minus 2 alpha beta, that means minus 2a, and the square of this whole thing. Correct only we are writing, no? Alpha plus beta whole square, right. Minus 2a square is given us equal to minus 30. Correct? This thing is given to us equal to minus 30. So we just put these values. Simple manipulation. Now we'll have to solve. This thing will become minus 60 minus 60 1 by 4 into 2, so minus 1 by 1 by 2 minus 2a whole square minus 2a square is equal to minus 30. A's value, possible values of a we need to find. So open the square, it will become 60 plus 4a square minus 4 into root of 60. Right? This will become 60 square of this plus square of this minus 2 into 2a into this. So this will become plus. No, minus only it will remain. Kya? Yeah, it will remain minus only. Minus 4 root 60 it will become. Sorry. Minus 4 root of 60 it will become. And minus 2a is also there. Minus 2a square equal to minus 30. So we only have a square. Oh, here a will come. Here also a will come. 2ab, right? So a will come. Now we have a quadratic equation. A square minus 2 root 60a and plus 40, no, plus 30. Plus 9, this will be, wait, just a minute. Let me put it over here. So 60 minus 30, 30. 60 plus 30, 90 it will give. 4a square will have minus 4 root 60a will have plus 90 plus 90 equal to 0. Correct? This is what we are going to have. If we are doing something, wait, 4a square minus 2a square, this will become 2a square only. This will remain 2a square only. what am I doing? 2a square, okay, this will become a square minus 2 root 60 a plus 45 equal to 0. This we can solve. Root 60, 15 fours, so 2 root 15, okay. Wait, they have asked only for product. Okay, product, this is a quadratic equation, product will be equal to c by a, that means 45. So answer is very simple here. We don't need to do any calculation after this. Product of all possible values of a will be equal to 45. Simply we can tell. Okay, product of all possible values of a. So don't get, if this type of equation, see, they are not going to give you a very easy equation in quadratic equation question. They'll give you something looking very tricky or difficult, but you can make it always easier for yourself. Okay, relation between coefficients and roots, basic concept. Very 2-3 concepts only are there. Nature, relation, Newton's identity, and one is location of roots. That also will cover. But on this very first category itself, many questions are asked. Number of possible solutions. These type of questions are repeated many times. Okay. One is this category. This type is also asked 2-3 times, a couple of times. This particular type is also asked. Different equations were there, but yeah, this was there. So power of a quadratic equation is another quadratic equation, and this is giving us 1. Here, one simple thought which you have to know, like which you need to apply, is power over power equal to 1. Either this is 0, this is 1. Can this be 0? No, sorry. Either this is 1 and this is 0. Correct? Or this is 1 and this is any real number. Correct? Either my base can be equal to 1. In that case, this can be any real number. We'll get 1. Or my base can be equal to any real number and this is 0. That will give me 1. One more possible scenario is there. You think about it. Sir, when you teach quadratic equations one shot. Quadratic equations one shot is there on the channel, Sumesh. It's there on the channel. Okay. In very much detail, it is there on the channel. All the concepts are covered, right, in detail. Please go ahead and have a look at that particular session. What I'm saying, equation, quadratic equations power is also a quadratic equation, and power over power is giving me 1. Okay. When can this happen? Either this is 1 and this is any real number. Correct? Or this is any real number and this is 0. Anything to the power 0 will give me 1, or 1 to the power anything will give me 1. There is no other possibility. Is there no other possibility? Think about it. Okay. Let's first go ahead. How to approach, that is important. So either I'll take this as 1, x square minus 5x plus 5 equal to 1. I'll solve this. In this case, what I'm getting, x square minus 5x plus 4. So this will become x square minus 5x plus 4 equal to 0. So 1 and 4, right? 1 and 4 minus x minus 1 and minus x minus 4x plus 4 equal to 0. So from here I'm getting x can be equal to 1 or 4. Two values I'm getting, right? Two values, 1 and 4 I'm getting. Okay. What else? Second thing which I'm going to check is, okay, if this is 1, then this can be any real number, right? This can be any real number. If x square minus 5x plus 5 I'm taking as 1, x square plus 4x minus 60 can be any real number, I cannot solve that. What is the other case? This is my case 1. Let's say I'm writing case 1. Okay. What is my other case? That this thing becomes 0 and this can be any real number. So I'll solve that. In that case also I'm going to get 1. So what will I have? X square plus 4x minus 60 equal to 0. This also I can have. So this is 10 and 4, 10 and 6 plus 10 minus 6. So this will give me x is equal to 6 or minus 10. I'll get x is equal to 6 or minus 10. Now these possible values I can get. Shall I sum all of them up and give my answer? Can I sum all of them up and give my answer? No. I'll have to check these values, right? See, this particular type is very common. Understand this very carefully, and you have to reach till end of this question, this particular type of question. Okay, don't just give your solution over here. If you have understood this concept, next thing, you'll have to check also, na? If I take x as 6, is this becoming 1? If I take x as minus 10, is this becoming 1? Yes or no? Because why you need to check? Because there is a possibility that on one of these values of x, this is becoming 0. You only need to check these two values. Why? These are fine. 1 and 4 are fine. 1 and 4 are fine. On this being 1 and 4, my base is equal to 1. Okay, base being equal to 1, not a problem. 1 to the power 0 is also 1. Okay, anything to the power 0 is 1. Correct? But if my power is becoming 0 at 6 and minus 10, when power is becoming 0, what if your base also becomes 0? 0 to the power 0 we cannot define. So you need to check these values. These two values, check with base. We'll have to check these values. Why? Because on these values, if my base also became 0, then what? What will I do? Correct? On these values, my base also becomes 0, then in that case, I'll have an undefined term. 0 to the power 0 cannot be defined. So I'll have to check these two. So I'll check. I'll check on x being equal to 6. What if my x is 6? Am I getting 0? If my x is equal to 6, or you can write like this, that x square minus 5x plus 5 when x is equal to 6. So 36 minus 30 plus 5. No problem. Right? Not a problem. This is not equal to 0. So not a problem. When your x square minus 5x plus 5, when your x is equal to 10, minus 10, 100 minus 50 plus 5, this is also not going to be equal to 0. So both are okay. Both the values are okay. Not a problem. Okay, both the values are okay. Now there is one more possible scenario. What is that scenario? If my base is equal to minus 1 and exponent becomes an even value. Exponent is giving me an even thing, even value. In that case, I'll have to consider that also. Minus 1 to the power of minus 1 to some even power. That will also give me 1, na? That is also going to give me 1. Correct or not? So I'll have to check that. How can I check that? I'll take x square minus 5x plus 5 equal to 1. I'll take x square minus 5x plus 5 equal to minus 1. When is this becoming minus 1? This is becoming minus 1 at 3 and 2, right? Either x at 3 or 2. This is becoming minus 1 at 3 and 2. Now, when this is becoming minus 1, when this part is becoming minus 1, what will happen to my exponent? What is my exponent? Exponent is x square plus 4x minus 60. So I'll check x square plus 4x minus 60 when x is equal to 3. Am I getting even or odd? My base is becoming minus 1 only at two values. And in those values, I'll have to check the exponent whether it is becoming even or odd. So 9 plus 12 minus 60. 9 plus 12 minus 60. What are we getting? We are getting odd. Is odd. So I'll not get minus 1. I'll not get positive 1. If minus 1 to the power even, then I'll get positive 1. But here, minus 1, when x is 3, when x is taken as 3, in that case, my power is becoming odd. So I'm not going to get plus 1. Now, what will happen to x square plus 4x minus, minus 60 when I take x as 2? Because when x is 2, base is minus 1. When x is 2, what is my exponent? My exponent is 4 plus 8 minus 60, even. This is even. So I'll have to consider this solution also. X is equal to 2 is a correct solution. X is equal to 1 and 4 are correct. X is equal to 6 and minus 10 are correct. So 1 plus 4, 5, 5 plus 6, 11, minus 10, 1, 1 and plus 2, 3. 3. 3 is my correct answer. Sum of all x satisfying. 5 plus 6, 11, minus 10, 1, 1 and plus this, plus 2. Only these are correct solutions, correct possible values of x. So में दे दो good score क्या होगा हो जाएगा so 3 भी वैल्यू हाँ yeah in practice form also you can take good score. Try to, if you are asking about good score, 200 by 300. Okay, that's a benchmark now. Try to reach that level, then you don't need to worry, right? Scores definitely are going to decrease because of removal of that optional thing and negative margin included. But yeah, even now the safe score. Next thing, yeah, before this, Newton's identity. I'll just remind you Newton's identity. Very simple question on Newton's identity will come if they come from quadratic equation, and students miss this part and they are not able to attempt Newton's identity question in exam. What does Newton's identity say? It says if ax square plus bx plus c is equal to 0 is a quadratic equation whose roots are alpha and beta, and there is some sum of roots defined, sum of powers of roots is defined as Sn. What is Sn? Sn will be defined like this: alpha to the power n plus or minus beta to the power n. A term S of n, sum of n, S of n will be defined like this: alpha to the power. So suppose if we are finding S5, so it means alpha to the power 5 plus beta to the power 5 or alpha to the power 5 minus beta to the power 5. If this is defined, then always A Sn plus B Sn minus 1 plus C into Sn minus 2 equal to 0 will always be true. This will be true. This is what Newton's identity says. It says that for a quadratic equation, if some Sn is defined as alpha to the power n plus or minus beta to the power n, then in that case, this will also be true. What does this mean? Suppose I'm taking S5. So alpha to the power 5 plus beta to the power 5. Then in that case, A into alpha to the power 5 plus beta to the power 5 plus B into alpha to the power 4 plus beta to the power 4 plus C into alpha to the power 3 plus beta to the power 3 will be also equal to 0. This is what identity says. Now let's see how we'll be able to see. It's not that in every book Newton's identity is not mentioned, and many times students solve the question without Newton's identity. But if you know Newton's identity, it will become easier for you to solve the question. For example, if we talk about this question, even if we don't know Newton's identity, what is the question saying? Read the question once, and whenever you'll see this Sn thing, no, that means you have to apply Newton's identity. Okay. Even if we don't know, let alpha beta be the roots of this equation and some Sn is defined like this for n equal to natural numbers, then which one of these is true? Okay, with Newton's identity, if you have understood the identity, this is 4-second question, 2-second question, right? Otherwise, what you can do, see, what do we need? We have S6, S5 and S4. S6, S5, S4. So find S6. What is S6? S6 will be alpha to the power 6 plus beta to the power 6. Correct? What will be S5? Similarly, what will be S5? S5 will be alpha to the power 5 plus beta to the power 5. What will be your S4? Alpha to the power 4 plus beta to the power 4. Right? Alpha beta are the roots of your alpha beta are roots of what? Suppose if you don't know, if you don't apply Newton's identity, then also these questions can be solved very easily. Alpha beta are the roots of this equation: 5x square plus 6x minus 2. Okay, so what will be true? If alpha is the root, then 5 alpha square plus 6 alpha minus 2 equal to 0 will be true. And 5 beta square plus 6 beta minus 2 equal to 0 will also be true. Correct? You need alpha to the power 6, right? You need alpha and beta to the power 6, 5 and 4. So if we multiply this with alpha to the power 4, what will happen? We'll have 5 alpha to the power 6 plus 6 alpha to the power 5 minus 2 alpha to the power 4 equal to 0. And this if we multiply by beta to the power 4, what we'll have? 5 beta to the power 6 plus 6 beta to the power 5 minus 2 beta to the power 4 equal to 0. Correct? Very easily you can identify the solutions to these. Now what? S6. Add these two. What do? We add these two. Add both. 5 alpha to the power 6 plus 5 beta to the power 6, that means 5 alpha to the power 6 plus beta to the power 6 plus 6 beta to the power 5 plus beta alpha to the power 5 plus beta to the power 5 minus 2 alpha to the power 4 plus beta to the power 4. What is this? Alpha to the power 6 plus beta to the power 6 is S6. So this will become nothing but 5S6 plus 6S5 minus 2S4 equal to 0. This will be your final answer. So directly also, this will be correct. Directly also, you'll be able to mark. Hi Shashti, how are you? But if we knew the identity, we can very easily mark, right? What does the Newton identity say? Just now told you. A into Sn plus B into Sn minus 1 plus C into Sn minus 2. What is A? A is 5. 5 into Sn. N is starting from 6. So 5S6. 5S6 plus B into Sn minus 1. That means this is N now. N is 6. Right? So B into Sn minus 1. That means 6S5. Right? Minus 2 into Sn minus 2. 6 minus 2. 2 into S4 equal to 0. Directly also you'll be able to mark. Newton identity questions are asked very frequently. Remember this identity as it is. So that these type of questions can be solved in seconds without wasting any time. Right? Otherwise also you'll be able to solve, but see how much difference is there. This much of thinking and manipulation we'll have to do, and directly we'll be able to mark the answer. Let's see a couple of more questions on this. This is from 2017. Your equation is given to you: x square minus x minus 1 equal to 0. Roots are alpha and beta. N is equal to 1, 2, 3. An, instead of Sn, they defined An. Right? An is defined. What is An? An is defined as P. Okay, let's not write it. Right? Look over here only. An is defined as some P alpha to the power n plus Q beta to the power n. Now alpha beta are the roots. That means alpha square minus alpha minus 1 equal to 0 is true. And beta square minus beta minus 1 equal to 0 is also true. A12 they are asking us to find. What will I do? I'll multiply these two. Alpha term is multiplied with P. So what will I do? I'll multiply this with P alpha to the power. I need 12, right? I need 12. A12 I need. So I'll multiply with alpha to the power 10. Right? So what will I get? Wait. What will I get? I'll get P alpha to the power 12 minus P alpha to the power 11 minus alpha to the power 10 equal to 0. Right? And I'll multiply this one with Q beta to the power 10. What will I get? Q beta to the power 12 minus Q beta to the power 11 minus minus beta to the power 10 equal to 0. I have this. I need to find A12. Have I got A12? What will be A12? What will be A12? A12 will be nothing but P alpha to the power 12 plus Q beta to the power 12. This will be A12, right? Can I find it from here? Correct? I can easily find from here. I'll just add these two. Okay. So when I'll add these two, I'll get P alpha to the power 12 plus Q beta to the power 12. That means I'll get A12. Right? Minus P alpha to the power 12, 11 minus Q beta to the power 11. That means I'll get minus A11. Minus alpha to the power 10 minus beta. Oh, sorry. P also will be coming here. P also will be there. No? Where did I forget P? Right? Minus P alpha to the power 10 minus P beta to the power 10. So this will become my minus A10 equal to 0. This will be correct. So what will I get? Which option will be correct? A12 will be equal to A11 plus A10. A11 plus A10. Very easily marked. Advanced question it is, but Newton's identity, very small concept, but we miss that sometimes, or we don't revise that. Don't do that. Very easy question will come from Newton's identity. So try to achieve marks in this part at least. Okay. Last year question, Newton's identity only. See, x square minus x minus 1 equal to 0. Roots are alpha beta again. They have defined Sn as sum 2023 alpha to the power n plus 2024 beta to the power n. In the options, they have given S10, S11 like that. Okay. Tell me, what shall we do? Which option? Try to do it once on your own. Sorry, just a minute. If you understood the identity, try to do this once on your own. Tell me the answer in the chat box. By looking at this itself, can I say it's starting from S12? Correct. So can I say S12 minus S11 minus S10 will be equal to 0? This is what Newton's identity says, right? This is some this is defined as some Sn. Okay, not a problem at all, right? So what we'll do, we after looking at this, we can say this at least, right? S12 minus S11 minus S10 will be equal to 0. And if we can say this, then I think there is no problem in saying that S11 will be equal to, sorry, S12 will be equal to S11 minus S10. Oh, this option is wrong. Yeah, S12 will be equal to S11 plus S10. Yeah, here it will be S10. Option is typed wrong. You using Newton formula, Newton identity. Correct. Exactly. So S12 will be equal to S11 plus S10. Directly we can say. We don't need to. Oh, acha, that option is there. Wait. This option is there. Simple one line question, right? Newton's identity last year only. This year only. Not even last year. 2024. Okay. Easily you can mark. So be thorough and practice questions from Newton's identity. 2023 also. Again Newton's identity. Whenever you see something like that, no, big powers, quadratic equation and dealing with big powers, you should get the hint that Newton's identity is going to be used over here. Give it a try once. Read the question. Without Newton's identity also you'll be able to do, but manipulation is important. See, look at this thing. Look at this thing. See, here a and b are the roots of this equation. This is given to us. So can we go ahead with a plus b equal to minus 7 by 1 and a into b equal to minus 1? How will we go ahead with that? A into b and a plus b will not help us. Powers are big. So Newton's identity is going to be used, or we'll have to manipulate the question in some other direction. Higher degree can be written in linear form. Very good. This is RA theory of, my god, typical name to say. Okay, correct. We can say this. This thing can we just simply write as a to the power 17 if we take common. Here we'll have a to the power 4 plus a to the power 4 plus 1. See, a to the power 21, a to the power 17 I've clubbed. A to the power 21 plus a to the power 17 if I club and add, I'll get this. Similarly, b to the power 21 and b to the power 17, I can take b to the power 17 common. And what will I have? I'll have b to the power 4 plus 1 divided by a to the power 19 plus b to the power 19. Let it be like that because 17 is not there. We could take common, but let's see it like this only. Just solving it with another way. You can use Newton's identity also. You can define Sn and then approach with it. Not a problem. But one more method of doing this. If you define Sn as a to the power n plus b to the power n, that will also work. Right? That will also work. You can solve in that direction also. A few more steps will be included, but that's okay. That will work. Now, our objective is to find a to the power 4 plus 1. Correct? I know a, b are roots of this. This thing x square minus 7x minus 1, a and b are roots. Correct? So with this, I can easily find a to the power 4 plus 1 and b to the power 4 plus 1. Very easily. How? Because see, a square minus 7a minus 1 equal to 0 will be true. From here, what I can say? A square minus 1 will be equal to, oh sorry, wait, just a minute. 7a minus a square. Or a square minus, we can say, no problem. A square minus 1 equal to 7a also, we can say. Now with this, we can find a to the power 4 plus 1. Correct or not? Try to think. Just square both the sides, na? Square both the sides. Square both the sides. When you square both the sides, what do you have? A to the power 4 plus 1 minus 2a square is equal to 49a square. So this will give you a to the power 4 plus 1 equal to 51a square. Okay, this will come in terms of a square. See, a to the power 4 plus 1 is coming equal to 51a square. So why am I saying leave it like that? Because a square and a to the power 17 will give me a to the power 19. Correct? Similarly, you'll have b to the power 4 plus 1 equal to 51b square, because same thing is going to happen. Same thing is going to happen. Correct? So these two things you can use over here. What will you say? A to the power 17 multiplied with a to the power 4 plus 1, which is 51a square. Similarly, b to the power 17 into 51b square divided by a to the power 19 plus this was b to the power 19. This will give you 51a to the power 19 plus b to the power 19 divided by a to the power 19 plus b to the power 19, and you know this can be cancelled and answer will be 51. Integer type. Very easy questions will come in this scenario. Small manipulations you'll have to do. You have to attempt these questions if they come in your exam. Practice more if you need to, but don't forget this. Okay, don't forget this. If class 12 students are listening to me, then this part can give you extra 4 or 8 marks. Trust me. Right? Newton's identity, revise this part very carefully. Okay, definitely if you will see 2022, 23 and 24 papers also, no, you'll see questions from this particular thing definitely coming there. Okay, so don't forget this. Okay, next thing, let alpha and beta, this year question again, 2024. This is one more variety which comes. Pay attention, please. Have a look at it. Try to read the question and attempt it. Let alpha and beta be the roots of equation x square minus 70x plus lambda equal to 0, where lambda by 2 and lambda by 3 is not a natural number. That means lambda is not a, what does this mean? As soon as you look at this thing, this should come in your mind. Lambda by 2 is not a natural number. That means lambda is not equal to 2 into, lambda is not a multiple of 2 and lambda is not a multiple of 3. Correct? You know, my name is Aditya Sharma. Okay, that's Aditya Sharma. Great. Yeah, that name I know. That name I know. 51. Lambda by 2 is not a natural number. That means lambda is not a multiple of 2. Lambda by 3 is not a natural number. That means lambda is not a multiple of 3. This should directly hit your mind as soon as you read this part. After that, read the question ahead. If lambda assumes means takes the minimum possible value. If lambda takes its minimum possible value, then this thing is equal to what? And here, alpha, beta are the roots, and difference of roots is also being used. So that thing, you know, square root of d divided by mod of a. Okay, now what to do? See, if first information you understood correctly, now try to go ahead, move ahead with the question and try to think of your first step. This thing is given to you. Sir, why there is no physics classes? Why there is no physics classes? Last physics class, when did it happen? Can you tell me? Random questions. When was the last physics class? Recently, I think work power energy was taken. No, not work power energy. Yeah, work power energy only was taken. Maybe there can be some reason. Maybe sir is traveling or some other health issue or something. Otherwise, it'll come regularly. Don't worry. When he comes back, classes will be held on regular basis. Don't worry about it. Right now, pay attention over here. Okay. So now this is my quadratic equation and it's using lambda. No, I don't know the value of lambda. I don't know the value of lambda, but I know lambda is not a multiple of 2. It's not a multiple of 3 also. And lambda is taking its minimum possible value. So I'll try to make some equation with lambda where lambda is there. Only lambda is there on one side and rest of the things are on the other side. That should be my approach. So here lambda will be equal to 70x minus x square. Okay. Can we say that? Yes. And one more thing which I can write or use is that my sum of roots, which is going to be equal to 70, and my product of roots, alpha, beta, will be equal to lambda. Right? Minus b by a and c by a. This also I can use. Now, alpha, beta is equal to lambda. Okay, from here what I can say, lambda is equal to 70, x, if I take common, x into 70 minus x. Okay. Sorry, just a minute. Over here, think, now how can you, 20 day before, okay. Now how can you now how can you use this part? Lambda assumes its minimum value and it is not the multiple of 2 and 3. We need to know the we can also write, right? Over here we can also say lambda is equal to some alpha into 70 minus alpha. No problem, right? If we got one of the roots, we can find other root. And we also know this relation will be true because alpha and beta are the roots of this equation. So this will satisfy alpha or beta. So lambda is equal to alpha into 70 minus alpha. Now here lambda is taking its minimum value here only. lambda is taking its minimum value in this equation. In this equation, lambda is taking its minimum value, this equation. And lambda is not the multiple of 2 and 3. Correct? So, can lambda be equal to 1? Can lambda be equal to 1? 2, 3, 4, 5. What can be the value of lambda? 1 by 5. Acha, nahi. See, one more important thing which we are not paying attention at is alpha and beta belong to natural numbers. Alpha and beta, both the roots are natural numbers. Okay, alpha and beta both are natural numbers. Natural numbers. Natural numbers. If alpha is 1, beta will be 69. Like that. Now, if we take alpha as 1, beta will be equal to 69. Alpha beta will become equal to 69. 69 is a multiple of 3. Lambda cannot be equal to multiple of 3. Correct? If I take alpha as 2, let's say, see, okay, alpha as 1, if I take, beta will be equal to 69 and lambda will come out equal to alpha beta, which is 69, which is not possible because lambda is not a multiple of 2 or 3. Lambda is not equal to 2m or lambda is not equal to some 2n. It's 3n, 3n. Not a multiple of 2 and not a multiple of 3. Okay. So alpha cannot be equal to 1 because then lambda will become multiple of 3. Can alpha be 2? If I take alpha as 2, in this case what will happen? If I take alpha as 2, 70 minus 2, 68, 68 into 2, multiple of 2, right? In that case also, I'll not get lambda will be multiple of 2, which is not possible. If I take lambda as 3, 70 minus 3, 67, 67 into 3, multiple of 3. If I take lambda as 3, this here, if I'm taking lambda, if I'm taking alpha as 3, then this will become a multiple of 3. So I cannot take alpha as 3 also. Can I take alpha as 4? 4 is a multiple of 2 only. So if I take 4, it will lambda will become multiple of 2 again. Not possible. First value, minimum value which alpha can take is alpha equal to 5. Because on alpha equal to 1, alpha equal to 2, alpha equal to 3, alpha equal to 4, and alpha equal to, and alpha equal to 4, we are getting lambda as either multiple of 2 or 3. At 5, this will not happen, right? This will become a multiple of 5. 65 into 5. Not a multiple of 3, not a multiple of 2. So lambda's minimum value can be 5. If lambda is equal to 5, lambda's minimum value can be equal to 5. In that case, I'm sorry, alpha's minimum value. Alpha's minimum value is 5 and that only will give me lambda's minimum value. Alpha's minimum value is 5, that only give me lambda's minimum value. That means 5 plus beta will be equal to 70. So beta will come out to be 65. Okay. Beta will come out to be 65. And your lambda will become alpha into beta, that means 65 into 5. 3, nahi, 325. 65 into 5, 325. So lambda came out to be 325. Now what do we need to find? We need lambda here. We need lambda over here. Alpha and beta we have. Not a problem. Alpha and beta both we have. Alpha is 5, beta is 65, lambda is 325. We'll put over here. And what do we get? So this will become 5 minus 1, that means square root 4, plus 65 minus 1, that means square root 64, into lambda plus 35, 325 plus 35. 365, right? 360 actually. 360 divided by mod of alpha minus beta. Mod of alpha minus beta will be 60, right? Here we'll have 60. So this will cancel this 6 times, and this will become 2 plus 8 into 6. 60 will be your answer. 60 will be your easy answer. Okay, small minute thing. Here main thing was finding the minimum value of lambda. Finding the minimum value possible for lambda. Answer will be 60. Now next thing is the Newton's identity, nature of roots, relation between roots and coefficients. All these parts are covered. These are the varieties which you can expect from these parts of the chapter. One more thing which is pending is location of the roots. Very important concept. Recently from 2-3 years we don't have many questions from that part, not many, but yeah, questions are there using that part. But before going to the nature of roots question, I think next only is nature of roots. Yeah, next only is nature of roots. I want to explain you, I want to make you revise the nature of roots part once. Okay, let's revise the nature of roots part. So there are 5 to 6 varieties which this part will involve. First one is location of roots, not nature of roots, location of roots, where the roots will lie. For example, if my equation is some y is equal to, my function is, right, if my function is some f of x equal to, if I have a quadratic function ax square plus bx plus c, right, and if I plot this, I'll get something like this. Okay, right, I'll get something like this. Let's not use the y-axis. I'm going to get something like this. Now they'll ask you 4 to 5 different varieties in this. First varieties is, they'll say that for this equation ax square plus bx plus c equal to 0, if both the roots are greater than some k. Suppose they want you to know, they want you to find that for what value, or for some for what equation, or for what uh, condition both the roots of this equation are greater than some k. So first part is both roots greater than k. So roots are existing and both roots are greater than k. I'll give you a small shortcut concept how to apply. So here there will be some k, right? Then only both the roots will be greater than k. If they're asking you this, that both roots are greater than k, either this is the possibility or this is the possibility, right? In this case also both roots are greater than k. There is some k over here. In this case also both roots are greater than k. This will happen when a is greater than 0. This will happen when a is less than 0. And if both roots are greater than k, then only one condition you have to apply. Write down this condition. If you want both the roots to be greater than some value, then two conditions. First of all, both roots should exist. So your b square minus 4ac, that means your determinant should be greater than 0. Otherwise, how the roots will be real and greater than that given number? Okay, we cannot compare a complex and real number. So there should be real roots. So b square minus 4ac should be greater than 0. Then second condition is a into f of k. That means a is positive. In this case, f of k will also be positive. So a into f of k will be greater than 0. Here also see, a is negative, f of k will also be negative. So negative into negative, positive, right? A f of k should be greater than 0. Second condition which you have to apply. And one more thing you can apply, although from these two only your answer will come, but minus b by 2a. Minus b by 2a will be between these two roots. Minus b by 2a will be between these two roots. Okay, midpoint. That's what you find. So minus b by 2a, this thing should be greater than 1. If these two are not giving you appropriate answer, one more thing you need to apply, then this will be greater than k. So minus b by 2a will lie here, somewhere over here. And here, this will be minus b by 2a. So these three conditions you have to apply. This is first variety in location of roots. Okay, you can note it down if you want. Three conditions. If they want that both the roots are greater than some value, then these three conditions you apply, your answer is sorted. Second variety or second category which they can ask is that both the roots are less than, same thing, this time we applied greater than. If both the roots are less than, both roots are less than k. Both roots are less than k means k is lying somewhere over here. K is lying somewhere over here. Alpha, beta, both are less than k. So here, I don't need to tell you the conditions. First condition is d should be greater than 0, root should exist. Right? Did I add equal to? Yeah, equal to will also be added. Use equal to. Second, a f of k will be positive in both the cases. A into f of k will be positive for sure in both the cases. And third, only third condition will change in this case. Your minus b by 2a will be less than k. Here we had greater than, and here we'll have less than k. Okay, this is the second variety or second category. Third one, that k lies between the two roots. They can also ask that k lies between the two roots. K lies between the two roots. What will be the conditions in this case? K lies means k is somewhere over here. Here is k and alpha beta are over here. Or here is k and alpha beta are over here. This also they can ask you. In this case, what do you need to do? Be greater than, in this one, only one condition you actually need to apply. You don't need to apply many conditions. Here, only one condition will work. Because this will happen only in one case. Right? This will happen only in one case. What can be the case? See, a is greater than 0 over here. And if you find f of k, it will come less than 0. Here, a is less than 0, but if you apply f of k, it will be greater than 0. So, a multiplied with f of k will always give you less than 0. And a multiplied with f of k will only happen if k is lying between both the roots. So, this condition is enough. You don't need to check anything else. If a f of k is, in no other case it is possible. See, suppose if roots are not existing, right? A is positive here. F of k will always be positive. So, a f of k will be positive. So, this is not going to happen. That means that k does not lie between the roots. That means here, suppose if we check for this, suppose this is the scenario, k is lying outside. Will a f of k be negative? No. A f of k will be positive here. F of k will be negative, a will be negative, so a f of k will come out to be positive. So, a f of k negative will only come if your roots are, if your k is lying between both the roots. So, if they ask you that for what condition k will lie between both the roots, then just apply a f of k, which will be less than 0. This condition is enough to apply to find the relation, right? One more condition they can ask you, both roots, just a minute, both roots are between some two values. Both roots are between, let's say, k1 and k2. Sometimes they can ask you like this, that suppose your roots are between k1 and k2. So in this case, what conditions? Here first you'll have to make sure that your d, that means your b square minus 4ac, is greater than 0. See, why did we not check b square minus 4ac greater than 0 over here? Because if b square minus 4ac is less than 0, in that case af of k cannot come negative. It will come positive only. Okay, suppose this is the case, d is less than 0. So af of k will come positive, it will not come negative. So we don't need to check anything else in this case. Okay, here first condition we'll have to check is that roots exist. Because see, if irrational, sorry, if complex roots we are having, then this thing will not happen. No, so first thing we'll have to check is b square minus 4ac is greater than or equal to 0. Second thing which we need to check is your a f of k1, a into f of k1 should be, in this case a is positive, f of k1 is positive, a is positive, f of k2 is positive, so this is greater than 0, and a f of k2 is also greater than 0. In this case a is negative, f of k1 is negative, so negative negative positive, a is negative, f of k2 is negative, so negative negative positive, so these both will be true. Rest, fourth condition which you need to check is your minus b by 2a. That means this point, your minus b by 2a is greater than k1 and less than k2. That's it. This much you check and this much you apply and you'll get your answers. One more possibility is there. One more category can be there. They can ask you that find the condition in which one k2 lies between the roots and k1 lies outside the roots. They can ask you this, right? This is also possible like this, that k1 lies here, k2 lies here, something like that. Or so basically they'll ask you exactly one root between k1 and k2. Exactly one root between k1 and k2. From here, let's move this. Yeah. Exactly one root between k1 and k2. So this can be the condition. In this case, also one condition. In this case, if they ask you, if they give you the condition, if they give you the, in question, if they give you that only one root is between k1 and k2, then in that case, see, a f of k1, or not even a, f of k1 into f of k2, f of k1 into f of k2. Here f of k1 will be positive, f of k2 will be negative. Here f of k1 will be positive, f of k2 will be negative. So here just apply f of k1 into f of k2, which will always come out to be negative. And this will only happen if exactly one, even if, suppose, even if I put k1 here, k2 here, then also f of k1 into f of k2 will be negative. If I put k1 and k2 over here, then f of k1 into f of k2 will be negative. If both roots are between f of between k1 and k2, then this will not be the possible case. If both roots are between k1 and k2, then f of k1 into f of k2 cannot be negative. So exactly one root between k1 and k2, then f of k1 into f of k2 will pakka be negative. And we can see that with the graph. Apart from this, I don't think they can ask you anything except one thing. See, what did we discuss? Discussed between, this is done. Both roots lying outside. Yeah, one more thing we can discuss. 6 categories, both roots are outside k1 and k2. Till now we discussed both roots are inside k1 and k2. What if both roots are outside k1 and k2? This means what? This means k1 and k2 are somewhere over here. K1 and k2 are over here. Then only your alpha and beta can lie outside k1 and k2. They can ask you this also. And I think this condition you can pakka very easily. You can say what will be the condition over here. Here a, in this case a f of k, sorry, in this case a f of k1 will be negative and a f of k2 will also be negative. In this case a is negative, f of k1 will be positive, so a f of k1 will be negative, a into f of k1 will be negative, and a into f of k2 will also be negative. Or you can apply a into f of k1 into no, you have to apply like this only. Two cases you'll have to check. See, in both the cases, a into f of k1, a is positive, f of k1 will be negative. So a into f of k1 will be negative. Here, a is negative, f of k1 is positive. So a into f of k1 will be negative. Same thing for k2. So a into f of k2 will also be negative. This will happen when both roots are lying outside k1 and k2. So these 6 conditions you have to remember. Not remember, you can easily understand also if you have understood this very carefully. Based on this also questions are asked. This is called location of roots. For example, let's see a question from 2023. The number of integral values of k for which one root of the equation, this is the equation 2x square minus 8x plus k equal to 0. I'll write 2x square minus 8x plus k equal to 0. This is your equation. It has two roots, let's say alpha and beta. Okay. Lies in the interval 1 and 2, and its another root lies in the interval 2 and 3. Have you understood? It's simply a question of location of roots. 1, 2 and 3. Right? 1, 2 and 3. So, wait, x. Let me solve here only. 1, 2 and 3 means, let's say 1 is here, 2 is here, 3 is here. One root lies in the interval 1 and 2. 1 and 2. Okay. And other root lies in the interval 2 and 3. So that means something like this would be the graph. Why am I putting, why am I making a upward parabola? Because my a is greater than 0, right? A is greater than 0. 2 coefficient. What is a? A is the coefficient of x square which is greater than 0. So upward upward graph, upward opening. And why between 2 and 3? Because one root alpha should lie, let's say alpha is lying between 1 and 2 and beta is lying between 2 and 3. One root lies between 1 and 2, another root lies between 2 and 3. This can only be the case. So in this case, my f of 1, I can, even without remembering the conditions, I can check. I can make the conditions. F of 1 will be greater than 0. Can I say that? Yes, my f of 1 will be greater than 0. So f of 1 will be, what will be f of 1? F of 1 means 2 into 1 square, that means 2, minus 8 into 1, minus 8, plus k will be greater than 0. So this gives me k greater than 6. 2 minus 8 minus 6, so k greater than 6. My f of 2 will be negative. Yes, definitely my f of 2 will be negative. What will be f of 2? F of 2 negative. So f of 2 will be 2 into 4. So 8 minus 8 into 2, that means minus 16, plus k is going to be negative. So this gives me k is less than 8. Very good. What else? F of 3. F of 3 will be positive. F of 3 will be positive. If I find f of 3, graph will be here. F of 3 positive gives me 9 into 2, 18 minus 24 plus k. Okay, this is giving me a positive, no? Positive. This is again giving me same thing, k greater than 6. So k is greater than 6 and k is less than 8. So basically I can say my k lies between the interval 6 and 8. What are they asking? Number of integral values of k. Integral value. What is the integer between 6 and 8? Only 7. Only one integral value of k will be there. Number of integral values they've asked. Okay, so only one integral value, only when k is equal to 7, in that case, one of the roots will lie between 1 and 2 and another root will lie between 2 and 3. That is the condition. Without remembering the conditions also, I can plot and check, right? I can always do this. One question from, okay, this is also location of roots. I couldn't find from the past years. There are, but because of lack of time. But this is a good question. Sometimes, why I have put these two questions, because sometimes students think that location of roots, 6 conditions, 6, 7 conditions, very difficult, very tricky. No. If you have the idea of equation, if you have the idea of function, simple function, then also you'll be able to do these questions. What are they saying? For all x, x square plus 2ax plus 10 minus 3a is greater than 0. For every x, if my f of x is ax square plus bx plus c is always greater than 0. Always greater than 0. Is it possible? Is it possible for this type of curve? No. For some values of x, the curve is going below x-axis. Correct? So no. For all x, I cannot say that for all x, my f of x will be greater than 0 in this case. I can only say this if my graph is not touching the x-axis. Because even if it is touching the x-axis, for one value of x, my f of k will be equal to 0, and it is not, for my f of x will be equal to 0, and it is not given equal to 0, it is given simply clearly given greater than 0. That means my graph, my curve is not even touching the x-axis, it's always above the x-axis. Always above the x-axis simply means d is less than 0. Why? Because see, over here a is greater than 0, that's why I'm making upward parabola. Even for down, if it was downward, then here it will be less than 0. Okay, so this simply says that my discriminant is less than 0. Discriminant is negative. Only then I can get this particular situation. So discriminant negative, we can easily do b square minus 4ac. So 2a whole square minus 4 into 1 into c, that means 10 minus 3a. This I should get less than 0. What will I get? 4a square minus 40 plus 12a less than 0. This only I'm getting, right? So a square plus 3a minus 10 divide by 4. So this will become a square plus 3a minus 10 less than 0. This I know how to solve using wavy curve method. So what will be the factors? This 5 and 2 plus 5 minus 2. So a minus a plus 5 and a minus 2 will be less than 0. Correct? So my critical points will be minus 5 and plus 2. I want less than 0. So only this part. That means a should be greater than 5, less than 2. A should be greater than minus 5 and less than 2. Simply mark this. So it's not necessary that location of roots, for location of roots, you have to always remember the theory. If you understand the concept also, you'll be easily able to solve location of roots questions. Practice this part very carefully. Apart from this, in quadratic equations specifically, there cannot be anything else asked, right? These questions are going to help you to revise, to practice, to have an idea which all types of questions, which of category of questions are going to come in mains from quadratic equation. So please try to solve. If you have watched the recording, then try to solve these questions once on your own. Similar type of questions, if you can solve, if you find, solve them also. If you find any other variety which we have not discussed, put it in the comments. That's all for today. I don't think any more questions are there. Yeah, that's all for today, and we'll come up with more chapters, more PYQ sessions in the upcoming sessions. Thank you. Take care. Keep having fun, and keep learning. Namaskaram. Vanakkam. Bye bye. Have a great day ahead.